Hey everybody, hope you're all doing well, and we're going to continue talking about practical uses of directing groups. And I believe the one I left you on, I don't want in red. The one I left you on looked like this. So let's walk through our game. What is the relationship between those two groups? Well, they're meta to one another. Okay? So that means we need to put things on in an order that would allow you for a meta positioning. The two groups are an iodine, which remember is I2 and nitric acid, and this propyl group. Now, we established last time that you can't just add 1-chloro or 1-bromopropane with a Lewis acid and expect it to go on the ring. It'll actually add in as the as the isopropyl group. So, what we have to do is this in order to pull this off. The acid chloride, which I never leave myself enough room to write, and aluminum trichloride. Sorry, folks, I paused to go to the bathroom and I cannot remember where I was. So, in order to put the 3 carbons on in a straight chain, then what you do is you take the acid chloride and the aluminum trichloride. You make the aromatic ketone, which you then chew off with, we'll use hydrazine and base this time. To make this. Now here's the problem facing this. The iodo group is very clearly an ortho-para director. The problem is, so is our alkyl group down here, and we are looking at a meta position. So whatever are we to do? Well, yeah, the alkyl group is an ortho-para director, but this puppy is a meta director. So the way to do this is you start with benzene. Hold on one sec. Josh, can you turn it down, please? So the first thing we put on there is the ketone, which is all part of our nefarious master plan, but the ketone there is a meta director. So now we iodinate it, and the ketone there will direct the new iodine to be in the meta position. Oops, too many carbons. And now we chew off the ketone using hydrazine and potassium hydroxide. And then our final product would look like this. If you didn't get this right away, that's okay. This requires a little bit of depth of thinking. If you looked at this and you still don't know what I'm doing and you're very scared and you don't think it's fair and you want the semester to be over with, I honestly don't blame you at all. But this is the situation where we are. All right? So, now then, let's go ahead and move on to another one of these. I want you to think about how to make this. All right? So take a couple minutes and think your way through that. All right, so the problem here is starting with bare benzene, the chlorination, I'm sorry, I got distracted by something. This is a meta positioning. chlorination, which is AlCl3 and Cl2, and iodination, I2 and HNO3, are the two groups that are on here. The problem we're facing is they are both para-directors, well, orthopara-directors. And this is a meta position. So before throwing your hands up, saying, tilt, I don't get it, it's not fair, go away, go die, I want you to think about something. I want you to spend a couple minutes thinking about how you can get those on there. All right? I'll be right back. All right. So here's what you do. There are a couple of routes that this can be done in. What you need to look for is a dummy meta director. Now, this is kind of the exact opposite of a protecting group, because the point of the dummy meta director is to go on first, or at the beginning at least, direct things meta, and then go away. And that's the hard one, getting things to go away. There are two routes with which you can do this, all right? Two routes. One of them is you nitrate. You add the NO2, which you then use tin and HCl to turn into an NH2, which you use nitrous acid to turn into the diazonium salt, and then you use H3PO2. I think I can never remember that one, to turn it back into a hydrogen, and it's this that does your dummy meta directing. So you nitrate it first, then you do whatever other reactions you want to do. Then you reduce the nitro to an aniline, the NH2 to a diazonium salt using nitrous acid, and then chop off the diazonium salt with H3PO2, I think, and add the hydrogen back. That is option one. Option two is this. Concentrated SO3 and H2SO4. This is your fuming sulfuric acid. And then this will add the sulfonic acid group onto the ring. All right? Now the sulfonic acid group right here, this is a meta director. Just like the nitro group. And now, what we do to get rid of the sulfonic acid group when we're done is dilute H2SO4. More water, and it takes the SO3 group out, and you go back to the hydrogen. So one way that you could work to build this would be, you start with benzene, concentrated sulfur trioxide, you generate the sulfonic acid. Now you can, what the hell was on there? Iodine and chlorine. Thank you. I2 and HNO3. Man, I got a fetish for that reaction. Iodine goes there. Chlorine. Aluminum trichloride goes here. And then finally, dilute H2SO4 takes you back here. There's one other way you can do this, and it's with the nitro group. And we get nitrobenzene. Now, let's iodinate this. I2HNO3. But now, tin and HCl which you then react with the nitrous acid to get to here. Now, I guarantee most of you out there right now are going, trust me here, because we want to go to where there's a chlorine in that meta position. So all we need to add here is copper 1 chloride, and we get our product. So there are more than one way to skin these cats. All right, so I got one more I want you to think about. Here's what I want you to think about. I want you to go from benzene to this. And here's what I don't want you to do. Overthink the shit out of this, because you don't need to. It's actually way easier than it looks. All right? So, give this a try. I promise you, this is not that involved. It makes you think about what we're covering now and what we've covered before. All right? So, this is it for the day. I'll have a couple more on tomorrow morning, but there will be no new material after today. From here on out, all the views are reviews, ideas on how to use the reactions, etc. All right? So, Sick Transit Gloria New Material 326.